112. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today, we'll talk with Alex Merced to understand the challenges associated with disparate catalog systems and how the REST catalog interface effectively addresses these issues. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the data engineering community around the world, drop me an email or an email to this marketing email. If you yourself are interested in giving a data engineer's lunch or speaking at our sister event, Cassandra Lunch, please reach out to me or this marketing email. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data. You can find out more about all the various different groups at datacommunitydc.org. At Data Engineers Lunch, we cover everything from the ingress and egress of data, plus everything in between. Databases, ETL, data wrangling, data engineering, all of the tools and processes in the data engineering world. If there's anybody here that's new, you'd like to say hi, what's brought you here, please put something in the chat. And don't forget to like and subscribe. A few rules: if you have a question, ask it. Please be polite and courteous to others. And as always, this is a community, so share what you know with us. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. Cassandra is our bread and butter. We also have a burgeoning Gen AI LLM practice to build custom chatbots and fine-tuned LLMs to help you talk to your data. Thanks to all of our sponsors, especially DataStax, George Washington University, and all of our institutional and organizational sponsors. If anyone has any job offers, you're looking for a job, please drop some links in the chat. If anybody has any meetups, hackathons, classes, or conferences that you would like to promote, please put those links in the chat as well. We are currently hosting Data Engineers Lunch Monday at noon Eastern, Cassandra Lunch Thursday at noon Eastern. We're looking at making some changes to our program, but I promise you we're going to continue to put out great content for all of your data engineering needs. We have released a series of runbooks that you can access through our site at anant.us/runbook, and we're really proud of what we've put out there for people to use to learn about Cassandra. All right, with that, I want to thank Alex for being here. Alex, really looking forward to your talk. Ready when you are.
Okay, sounds good. Let's do this. Let me share my screen. Hey, everybody. My name is Alex Merced. I'm a senior tech evangelist here at Dremio. Now, before I go through the presentation, I always like to put up this QR code up for a moment for anyone who would like to download the slides for this presentation. This particular QR code will take you to a Google Drive folder where you'll find not only the PDF for this presentation, but for several other presentations that I do. Again, most of them I've probably done live at some point, so you can probably find a version of it or multiple versions of it on YouTube if you want to see those performed. And some of them are talks that are coming, which some of them I'll be performing here on Anant's Engineers Lunch, so stay tuned. But basically what I'm talking about today is the Iceberg REST Catalog specification, okay? Basically making catalog interoperability happen, okay? But before we get into the topic, let me just, again, talk a little bit about who I am to level set. I'm a senior tech evangelist for Dremio. In the past, I have worked as like a software developer on the web and data sides. I'm a co-author of Apache Iceberg, the Definitive Guide. So this is a new book that just recently came out from O'Reilly. Basically, me and the others, we spent pretty much 2023 writing this book. It was a good time. If you want to get a free copy of the book, you can scan this QR code, and that will get you to where you can get a free PDF copy of the book. And I'm also the host of several podcasts, all of them available on iTunes and Spotify, including Gnarly Data Waves, which is our bi-weekly webinar series over there at Dremio. But I also have several podcasts where I just kind of opine on things all over the data world, whether it's Data Nation, where I just talk about trends and new developments in the data space, in the scheme of things, where I talk mostly about data modeling. Select Star from Data Lake, where I talk more about sort of data lake concepts, and Catalogs, Manifests, and Metadata OMI, where I talk about all sorts of really cool open source data projects. But that and all sorts of other links to content that I create can be found over there at bio.alexmerced.com/data. And for those of you who are interested in learning even more about Apache Iceberg, we're actually going to be doing starting a 10-session live Apache Iceberg crash course. So this is going to be a long form course, so 10 sessions, each one about ranging from between like 20 to 60 minutes a session, starting July 11th. The last session will be on October 29th. So if you want to be there and participate in those live, you can register by taking a picture of this QR code. If you're seeing this presentation after the presentation is over, because you're watching it on YouTube, you can still scan the QR code and it'll take you to where you can access the on-demand versions of those sessions. So scan it either way. But with no further ado, let's start getting into our feature presentation. So if we want to talk about Apache Iceberg and the Iceberg Catalog REST specification, well, we need to establish a few things. We need to establish, like, what is a data lakehouse? Because what is a data lakehouse? This was going to matter to why Apache Iceberg exists. Then we need to answer the question, what is Apache Iceberg? And then we can get to the REST catalog specification, just to kind of give you a preview of sort of the journey we're about to go on. So what is a data lakehouse? To understand what a data lakehouse is, you need to understand what came before. In traditional data systems, like databases and data warehouses, they essentially these pieces of software abstracted away many things, so you don't have to worry about them. You can just sit there and work with your data. They abstract the way the data is stored. Okay, when you're using a database like a Postgres or MySQL, you're not really thinking, oh, how is this data, manifested in my physical storage? It just kind of is there. You're not really concerned with how does it know which data belongs to which table. It just knows. How does it know how many different tables exist? The catalog. Okay, and then when I write an SQL query, how does it parse that SQL? How does it turn that SQL, that parsed SQL into a execution plan and then actually execute that query plan? How does that all happen? I don't have to worry about it because this is all abstracted away when you're using databases and data warehouses, which is very convenient and very great. And this is so why we generally like to use these systems for a good chunk of our data use cases. But the problem comes in when you start getting into more the analytics side. The types of use cases we have for analytics are growing. The size of the data for analytics is growing to the point where basically no tool can really satisfy all use cases. There's no sort of perfect tool because, again, everyone's kind of optimized for all different use cases. There's only so much engineering power to go around. So in this case, you live in a world where oftentimes you're going to want to use other tools. And traditionally what happens is that if I want to use multiple databases or multiple data warehouses, I'd have to kind of copy that data from system to system. So this creates a situation of how do I keep all these copies of my data consistent and synced up, the cost of actually doing those data movements, the time lost in doing those data movements that actually slow down the delivery of my end analytics and insight delivery. So the hope is, how can I just reduce all that? How can I make it where there's only one copy of my data that all my tools can work with? Because in that world, I'm moving the data less, which is going to cost me a lot less money, but I'm also going to be able to deliver that data faster to where it needs to be, whether it's training an AI model or building a BI dashboard. And again, traditionally databases, oftentimes we're thinking transactional type workloads. So we're thinking row-based data structures, while analytics, we think about like columnar-based data structures. Now, one place we have where we could store data that anyone can access is a data lake. Okay, so a data lake, essentially, all it is, it's a storage layer. Okay, it's like a giant hard drive where we just dump a copy of all our data. The difference is that typically a data lake is distributed because you're not just one person storing a couple gigs of data. You're oftentimes a large international or geographically dispersed enterprise trying to access that data, terabytes, petabytes of data across large geographical regions. So you use something like a Hadoop or a object storage like an S3 or ADLS to be the storage layer of that data. And the problem is these are just data files. These are JSON files, CSV files, Parquet files. So tools like Dremio, AWS Athena can go run queries on these data sets, but because they're just files, there's not all this other abstractions that help it understand it as a table, understand which tables you have, all these kinds of abstractions. You don't get the same sort of functionalities you do with a traditional database or data warehouse. So that doesn't quite solve the problem. But what if we did add those abstractions in? What if we created and said, okay, hey, use your storage layer. So use whatever you're storing your data in already. Use the same processing tool you're using to process that data to run queries against it. But we're going to give you some extra superpowers by creating that abstraction layer that allows us to identify what tables are on your data lake by saying, hey, we're going to have a table format like Apache Iceberg, allow us to take bundles of files and say, hey, that's a table. And then we're going to have a catalog like Nessie that says, hey, these tables exist in that data lake. So that way a tool like Dremio or AWS Athena can interact with the data on your data lake like it's a data warehouse. So thus you get this paradigm referred to as the data lakehouse, where essentially you're taking your existing processing tools and just laying them on top of your data lake, because table formats like Apache Iceberg and catalogs like Nessie make it just possible to interact with it like a database. So in that case, you don't have to move your data into 50 different tools, because those tools can all leverage the same storage. So that's what a data lakehouse is. And again, one of the key things there that made that possible was the table format, in this case, Apache Iceberg. Okay, and Apache Iceberg is one of a few different major table formats that allow us to take a group of files and identify them as a table. But Apache Iceberg and table formats generally go much further than just saying, hey, these 500,000 files are a table. They're going to provide us all sorts of ways to more efficiently scan those files. Okay, and generally the way Iceberg works is that everything kind of revolves around a catalog, which is going to be a big part of today's conversation. And essentially what the catalog is, it's kind of like, if you're familiar with like how the internet works, there's something called DNS, the domain name service. So the way the domain name service works, if I type in like google.com, okay, there's no computer called google.com. There's a number like an IP address, like a 127.32.65.123 address for that computer somewhere in the public internet network. But no one remembers these numbers. Like it would be really impossible to have to memorize the IP address for every website you want to see. So the domain name service, the DNS server, what it does, it maintains a list of, hey, okay, for this domain name, it points to this IP address. Okay, and then basically we can then send your request off to that computer to then fulfill it. That's essentially how the catalog works in Iceberg. Essentially, it's essentially a DNS server. Okay, essentially you say, hey, I'm looking for table A. Okay, well, really what you care about is where's the metadata for table A? Where's all that information about the table? Okay, and then the catalog will say, well, table A, well, the metadata is stored here, and will point you to where that data is stored. Okay, so a tool like Dremio can now say, hey, give me table A. It's located here on S3. I find that metadata file, and I can begin understanding that table and operating with it in the same way a database system or a data warehouse would understand the table internally. So again, we hit that catalog, that would point us to a JSON file, a metadata.json file that tells us like what the table schema is, how is the table partitioned, all these kinds of cool things. And then a table is made up of several different changes. Okay, so kind of like if you ever worked with code, you might have lots of commits, and each commit represents a change in your code, and you're able to actually like time travel to your code as it was in the past, because you can time travel to these commits. Well, in Iceberg, you have manifest lists. Each manifest list represents a snapshot or a point in time for that table. So every time you change a table, I add data to it, I subtract data to it, I change how it's structured, that creates a new snapshot. So I can specify which snapshot to go to, and it'll point me to the right manifest list for that particular point in time. And that manifest list is going to have a list of manifests, which are just groups of files. So each of these manifests is going to have a list of files with metadata on those files. And using this metadata, using the metadata in the manifest list and the manifest, Dremio can begin determining which files even make sense to open. Okay, so I might have 1,000 files in this table, but really to satisfy my particular query with my particular filters, there's really maybe only 30 files I actually need to open. Okay, and using the metadata here, I can determine that, which saves me the time of having to open and find nothing in the other 970 files. So basically, Iceberg is not only letting us know which files are the data, but is giving us the information so we can determine whether we need to scan all the files, so we can scan it faster. So that's the benefit of a table format on top of enabling things like ACID transactions, time travel, the ability to evolve tables, whether it's evolving their schema or their partition, all kind of things that we can do in a database or a data warehouse, and we just take for granted, but don't realize that there's a lot of stuff going on under the hood in a database or data warehouse. And what we're doing here is we're pulling it out into separate pieces, so that way you can sort of modularly put together your data warehouse. So instead of having to use the same tools because everything is bundled together, you can use a variety of tools because Apache Iceberg provides the standard way, the standard metadata layer that everyone can leverage. Okay, so that's what Apache Iceberg is. But as I mentioned, the catalog is a very big deal because how, like in the same way, like while when I go to google.com, Google servers do most of the work. I could never get to google.com if there wasn't a DNS server ready to route my request to Google servers. Okay, is that otherwise I would just get an error every time. Okay, so that act of routing those requests is pretty integral. So same thing with Iceberg. If I didn't have a catalog telling Dremio or Athena or Snowflake, hey, this is where that table's metadata is, then everything kind of falls apart. Okay, and there's lots of different things you can use as a catalog when it comes to Iceberg. Okay, but you need to generally have to have some sort of catalog. So again, essentially the catalog is sort of the traffic control center, like an airplane traffic control center for your Iceberg table, saying, hey, I'm looking for this table, here's where that table is. So all these different tools are trying to access your Iceberg tables on your data lake. It's a catalog that's going to direct traffic to the right information, to the right metadata files. Okay, and there's lots of different things we can use as a catalog. Okay, but again, it sits between your data lake storage where the actual tables are stored and your query engine that's going to do processing on that data. So one way you could do it, and again, essentially the role of a catalog is just to say, here's where that metadata file is. All it cares about is that one main metadata.json file, because from there you can discover all the other metadata files. So essentially, when you hit the catalog, it's just going to say that's where this is the particular metadata to look at, because every time the table changes, like there's a new snapshot, but there's also a new metadata file. So like the first time when we created the table, there was a v1.metadata.json. Then maybe we added some records. So there's a v2.metadata.json. And then maybe we deleted a few records. So now there's a v3.metadata.json. Well, for me to perfectly and accurately and consistently replicate the table, I need to know which one's the newest one. Okay. Now, theoretically, people would think it's like, wait, why do I need a catalog? Couldn't a tool like Dremio just go into the place where the metadata is and look for the one that has the highest version number? This is true, but this takes longer because it would have to, one, list all the files that are located in that directory to find, hey, what are all the metadata.jsons that currently exist? And then have to kind of loop through each one to figure out, hey, which is the newest one? Okay, so that would take longer versus just going to something that just says that's the newest one. Okay, and that difference of speed matters. Okay, so basically the catalog acts as a way to know right away which is the new metadata.json, which is the current metadata.json. Now, there's two ways this can be done. So sometimes you don't have an actual catalog server, like a server that's actually acting in that capacity. So there's something called the Hadoop catalog. That's the term for like the actual like class or tool or library that's used. But it's really just the file system catalog. It's the directions of how do I use the raw file system as a catalog. And the way this works is that every time you change your table, instead of updating some sort of separate thing called a catalog, it just creates a file called versionhint.txt. And inside this versionhint.txt file is the name of the current metadata.json. So every time I change the table and a new metadata.json gets created, this file gets updated to reflect which one's the newest one. That's fine. The problem is that not all storage systems have the same guarantees when two people try to update the same file at the same time. So what if you had two updates to the table, try to update this versionhint.txt at the same time? There is the possibility of inconsistencies depending on your storage system. Okay, so generally, this is why this is typically not recommended for production. Very useful for like experimenting with Iceberg or very small use cases, but generally this is not recommended. What's recommended is to actually have a server, to actually have a running service that actually acts as a catalog, because that can then leverage a database. It can have its own built-in lock mechanisms, ways to just prevent that multiple people updating the table at the same time. Okay, so that way you have those consistency guarantees. So there's a lot of choices, but essentially what they are is software. So instead of updating a file, you actually have a server that's doing all the sort of coordination of this stuff. Okay, the problem was there's a lot of them. Okay, I mean, there's like you can use the legacy Hive catalog, so Hive, which was data lake catalog before Iceberg and all these other table formats existed. You could use that. I could use just any old database, which is referred to as the JDBC catalog. I could use things like Nessie, Tabular, Snowflake. I could use AWS Glue, okay, Dremio's enterprise catalog. There's a lot of options. And basically, this is going to lead us to why we need the Iceberg REST Catalog spec, because the way all these catalogs were handled before was a bit chaotic. Okay, so for example, let's say I want to create a catalog. I would first have to design a server that basically does two things. It has basically what happens is that there's a base class in the particular programming language. So in Java, there's actually like a catalog base class that has all the particular functions that need to exist for a catalog to work with Iceberg. And I would have to go create that service that and then implement all these methods. Okay, so what would happen is that I would have to write a catalog server, and more than likely, I'm probably going to want to write that catalog server in. Well, I could technically write it in any language, so it doesn't really matter what I write this in, but more than likely, I'm going to want to write it in a language with Iceberg libraries, which are going to be Java, Python, Rust, and Go, because there are going to be certain Python operations I may want to do here. Okay, initially it was really simple. It was just basically catalog says, hey, give me a name. Okay, let me go find you the file location for that name. And then that's pretty much all the catalog does. But the problem is, the less the catalog does, then the more the client has to. So then what would happen is that for something like Hive, JDBC, Nessie, you would then have to write a custom library in Java to work with the Java Iceberg libraries. Then you would have to write a separate client in Python to work with the Python Iceberg libraries. Then you'd have to write a separate client in Rust to work with the Rust Iceberg libraries, and a separate client in Go. Okay, so basically you would have to write that same logic 4 times and then keep it updated, so that way tools in each of these languages could communicate with that catalog. Okay, so while Java's pretty, like the Java library and Java libraries are all pretty robust, and Python's probably like in the next in line for us most robust, with Rust and Go being sort of newer to the Iceberg library. It's just a lot of work you have to do just to maintain basic functionality. Okay, and again, on top of it, the amount of logic that has to be in the client is more. Okay, basically everything since a catalog is just basically returning you a location, so the catalog's not doing much. Each of these clients have to do the remainder of the work. So that just means having to implement more logic multiple times across multiple languages. Okay, so that's why this wasn't necessarily sustainable. And on top of it, every tool would have to then add that functionality. So for example, like a tool like Dremio, just because it supports Iceberg doesn't mean it supports every catalog. Because even though like something like Dremio is like written in Java, it would need to make sure that it has all the collection of all these different client libraries and then builds that functionality with separate UI pieces to use those catalogs into the UI. So you end up having the situation where you had tools that work with Iceberg, but they didn't have, this one had support for these catalogs. This one had support for these catalogs. So you had this sort of very inconsistent sort of world. So there was a solution, and that's the Iceberg REST Catalog. So in this case, what happens is you write a server, and there's a specification for different things that the server needs to do. Okay, so now the server can do a little bit more, can be responsible for a little bit more. Okay, which means the client can do a little bit less. Okay, and this leads to several benefits. Okay, so again, you can write a catalog in any language you want, long as you implement the specific endpoints that are specified by the specification in that server through a REST API. So again, it doesn't matter what the language is because everything is communicated via HTTP calls back and forth, the universal language of the web. So you would have your catalog server, and since they're meeting that specification, all the things the client has to do is just make those requests to the server. So that means a client can do a lot less, and the client can be reusable. So now the same REST client for Java can be used for all the catalogs. Okay, so instead of every catalog having to re-implement their client 4 times, they can just use the existing REST client for that language. So now all I have to do is just build a catalog that meets the REST specification, and guess what? Now it works anywhere that client works. So any tool that has REST catalog support just automatically now works with this catalog I created. Okay, and this is really beneficial. One, for if you're a company who's trying to build your own custom catalog solution that you want to offer to the public, guess what? That's going to give you support across many tools right away. Okay, if you're building an open source catalog solution, that's going to give you support across many tools pretty much right away, because they don't need to build support for your specific catalog. They just need to build support for this specification. Okay, and then all catalogs that adopt that specification become supported. But even more special is that there's times where companies just want to build their own custom catalogs for their specific company's needs. Okay, they build their own, companies like Netflix and others have built their own custom internal Iceberg catalogs that are integrated into all their systems. Okay, so this offers a way where every tool doesn't have to build specific support for that catalog. They just use this universal interface, and now even custom catalogs that are internal to one company can then be used with all your favorite tools, whether a commercial or open source. Okay, because again, everyone's agreed on sort of how the two sides communicate. That long as my server follows those rules, then you can use the existing client that already exists. Okay, making life a lot easier. So this gives you access to all sorts of tools that support this specification. So here's an example of many tools that support the REST catalog as a client. Okay, so you can connect to REST catalogs that support REST catalog using Dremio, Snowflake, Flink, Apache Spark, DuckDB, StarRock, Polars, etc., etc., etc. Okay, so you have really robust support and access to many different tools. And right now you have 4 open source catalogs that support the REST spec. Now, here's the thing to keep in mind. Just because they support the specification doesn't mean you can do everything with them. So a catalog can choose to not implement every action supported in the spec, which means that if I try to do that thing, then I'd get some sort of error or some sort of message saying, hey, this catalog doesn't support that specific operation. Okay, so like for example like Unity catalog, which is, so we have Nessie, Gravitino, Unity catalog, and Polaris catalog from Snowflake. But with like Unity catalog, generally that's more built for working with like Delta Lake. So they've implemented the REST catalog so you can read Delta tables that were translated into Iceberg using their uniforms functionality via that REST catalog specification, but you can't write to them. And I don't even think they've even bothered to implement those endpoints for that to even be possible. Okay, so in that case, like again, certain functionality, they can say, hey, we don't want you to have this functionality, so we won't implement those endpoints. So again, each catalog, just because they support that way to connect to it, doesn't necessarily mean they're going to have all the functionality. So you want to always do your due diligence on what each catalog does. Okay. And again, the catalog is very flexible, so that way different catalogs can offer you really unique features. Like Nessie offers Git-like functionality on your data. If you've been to previous talks that I've done, I've talked about this extensively, how it basically allows you to actually version your catalog. So that way, if you want to go back to where your catalog was previous changes ago, you can, allowing you to do time travel at the catalog level, not just the table level, and along with a lot of other really cool benefits. But if you found this really interesting and like to get hands-on with like Iceberg, just to kind of see this in action, this QR code on the left is actually a good hands-on exercise where you'll spin up things like Nessie and Dremio and make Iceberg tables right there on your laptop, so you can actually see how this works and how it feels like working with any other database, except you're not. You're just basically working with your storage and using a tool that's just working with files on your storage, but it feels like a full-on database and gives you that same on sort of easy usage. Again, giving you this real powerful paradigm where you have one set of data that can be used with multiple tools. And again, I come from Dremio, we're a data lakehouse platform that makes doing all this data lakehouse stuff a lot easier. So if you are after doing this exercise, if you're interested in going deeper with it, do definitely scan the QR code on the right to learn more. And then we're more than glad to help guide you on your Lakehouse journey. Okay, and then here are some more exercises. These are more end-to-end exercises where they start with you ingesting data from a particular data source all the way to building a dashboard. So if you want to kind of do the whole end-to-end data engineering experience, here's a few exercises where you can do that. And with that, that should be the end of the presentation. So I'll open it up to any questions that anyone has. So again, feel free to put in your questions wherever you're at. Again, thank you for being part of this presentation. And then I'm just going to put up one other thing back up from the beginning, because again, we'll be doing that Iceberg crash course. So if you want to do a deeper dive into sort of all aspects of Iceberg, you can sign up for that course by scanning this QR code here. But with that, I'll leave it open to questions.
Hey, Alex, I was noting that the way the stream is working, I think the upper right corner of this QR code is obstructed. Oh, maybe not. Maybe it's reachable now.
Okay.
But if you send me the link, I'll make sure it's posted in the description.
Okay, sounds good.
So there were a couple questions that came in. Will and I were wondering if you wanted to use something as simple as like Excel or Airtable as your data catalog, right? We're so sort of thinking about like taking a basic data inventory. What would be the disadvantages of that? When do you think you would start to run into problems that some of these more mature tools are going to solve for you?
Now, if you were to use the question would be, can you use Airtable as a data catalog? Because you can, if there's a way to connect to Airtable via JDBC, then theoretically, yes. Because there's a catalog called the JDBC catalog. So you can connect to literally anything that supports a JDBC connection and use that as a catalog. The downside with the JDBC catalog is, again, right now it doesn't support REST. Like there isn't a REST version of the JDBC catalog. There is like this sort of there is Tabular created like this tool that's sort of like a translator where you can plug in a class of an existing catalog and it'll essentially like translate the requests. But still, like right now, there isn't a REST catalog compliant implementation of JDBC catalog. So right now, you'd use the native JDBC catalog, and there's only two versions of it. There's a Python version and a Java version, and they don't work the same way. So you can get inconsistent behavior between both. So that's sort of the downside of it. It's just like there's just and then again, there's always the unpredictable things since there's so many different databases out there and different things you can connect to with JDBC, like how they might, how functional they'll be, can vary depending on which one you're using. If you're using like a Postgres MySQL, like just your everyday databases, it works fine. But also the issue is like tool support. Like not every tool supports JDBC catalog. So for example, like if you're using JDBC catalog, you can't load that up into Dremio and see those Iceberg tables because Dremio doesn't have support. And I don't think most tools do for JDBC catalog. Now in the future, that'll probably, because that's an open source library, I would not be surprised if someone creates a reference implementation for to allow you to use databases like basically a REST catalog server that you then just kind of proxies the request. Technically, what Tabular did kind of does that. Essentially by plugging in a Java class, like it's in a Docker library, it's in a Docker file somewhere. I don't think it's really meant for production. It was like more of a proof of concept for REST catalog, but I wouldn't be surprised if someone tries to create something like that that's more distributed and like enterprise grade. So that way people can just use. Technically you can already kind of do that. Like if you're using Nessie, you do need a backing database. So you can already kind of use like a MySQL or Postgres. So generally at that point, you might as well use a catalog service that already supports like REST catalog, like a Nessie, like some of the others that I mentioned, versus just a direct database. Because there's a specification, anyone can write their own catalog. So if you really just wanted to use, technically, if you wanted to use Airtable as your catalog, you could write a REST catalog server, and then basically you would just have to translate on the implementation side. Oh, here, let me make these API calls to the Airtable API to get these pieces of data and return them as they need to be formatted. It probably would be a lot more work than it's worth. But it theoretically is possible. You can now theoretically turn anything into a catalog if you're willing to go program the service for it.
Yeah, at Anant, we believe in not recreating the wheel. and not trying to remake something that has already, not trying to resolve a problem that's already been solved. Thank you. I did have another question
Mhm,
coming from the AI LLM world, right?
mhm.
AI LLM has become really multimodal, where you need to be able to process voice, images, text. How would a data catalog like Iceberg work with that sort of multimodal data challenge?
That's something that some of these catalogs are tackling. Because again, the catalog can do anything theoretically. It's like like for example, if I'm working with Iceberg tables, I'm working specifically with structured data. So in that case, I'm making the tool. So let's say a Dremio or whatnot, they're going to use the Iceberg libraries for the REST catalog specification to make a request to the catalog for those Iceberg tables. But it doesn't necessarily mean that the catalog can't have functionality outside of that.
Hmm.
So some of these catalogs are exploring that, where basically there's things that they do that are outside of just, hey, can I access these Iceberg tables? And they have other interfaces that are more specific to that specific catalog for you to access other assets on your data lake. So cataloging, different images or videos, or cataloging AI models that you might have sitting on there, or vectors or whatnot. They're independent of the Iceberg piece, but theoretically, like the catalog can then like extends itself to capture more and more information about your data lake, and then tools will have to build functionality for that other stuff. Like, so the Iceberg REST functionality really just captures the ability to interact with Iceberg tables on your data lake with that catalog. But again, the catalog can go further. It would just be separate functionality the end tools would have to build in to leverage that functionality of the catalog. And that's going to be probably like, that's like the big race now. So now that everyone's kind of settled on Iceberg, especially over the last month, with Polaris, which is one of the Iceberg catalogs being announced by Snowflake to be open source. Again, very big deal for Snowflake to be putting out a big open source project like that, and to put that kind of open support versus for Iceberg as they have been. And then Databricks, who's been created Delta Lake and has been a big backer of Delta Lake, pretty much been all in with Delta Lake to open source Unity catalog, and then purchase Tabular, which is the company created by the creators of Iceberg. That was sort of a very big signal that, hey, like, no matter how you cut it, Iceberg's going to be around. So now the question has become sort of, okay, if everyone's settling on Iceberg, which catalog? The catalogs are kind of newer. Like Nessie's probably the one that's been around the longest and most mature, but they're still like, as far as figuring out, hey, like what's their scope going to be and how far are they going to reach into your data lake. That's sort of like the where the competition is now. Like, hey, which catalog? What should these catalogs provide you? Uh, and who does it the best? Those will be the kind of like, that's going to be like sort of like the new uh, battle over the next couple of years.
Yeah, thank you for sharing that. Those signals that the market is sending are always really interesting to learn about. We do have another question from Will. Um,
Mhm.
is it worth using a data catalog like this as a business catalog, or are two separate ones smarter?
Got it. Okay, so I would say at the moment, a business catalog, something like a Colibra, is a separate thing than what this is. So the way I would put that is, what the Iceberg catalogs do is they allow your tools. So on a technological level, they allow your data to be discoverable by the tool. So it allows Dremio to know which tables you have, not necessarily like what a Colibra does, which allows a human to discover tables. So with something like a Colibra or an Elation or whatever, you have generally like this business, oftentimes a business glossary where I can look up business terms, but on top of it, see different data sets across different data sources. So I can see the full panel as an individual of what data exists at my company and actually request access. So it becomes this panel for me to, in a more human readable way, discover what exists, versus what the Iceberg catalog is doing. It's allowing a tool that understands Iceberg to be able to discover, hey, which tables do I have access to? But it's not me looking at like a window pane of tables, even though the tool might provide that for me. So like a tool like Dremio, when you connect to your catalog, Dremio provides you that sort of nice visual way to see all your tables. But the catalog itself is just more of a communication, a technological communication layer between the engine and the tool, or I mean the actual tables and the tool. So there's the Iceberg catalog specifically for discovering Iceberg tables at the tool level, and then there's your business catalogs like Elation, Colibra, which are for allowing your individual end users to be able to discover data at sort of the enterprise level. And I mean, I think eventually they will sort of intersect. So I wouldn't be surprised if you're starting, down the road as like the technological piece gets squared away, that they start expanding and capturing other types of metadata, so that way you can actually make all that kind of information more portable, and any tool could just load up that kind of data about your entire data lake from wherever. But again, something like a Colibra relation, again, they're not, because they're kind of separate from the direct access, they can capture your data like, they can let you catalog data from anywhere, not just your data lake. So there's different use cases. So I would have separate, like right now, I would think of them as two separate categories.
Thank you. And Will says thanks as well. So if there are no other questions in the chat, I'll give us just a moment here. Alex, I want to thank you so much for being here and sharing your knowledge with us. It's a really interesting talk, and you shared so many great resources. I think your next one here is scheduled for the end of July, so you'll be back for another round on Data Engineers Lunch soon.
Yep. So I'll see you all there. Thank you very much as always, and I'll see you around.
Great. Thank you. Bye, everybody. Okay. The stream is done. I'm
Cool.
up in the backup recording. So I